good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. Now today we will start our new module which is called Fluid Kinematics and Fluid Dynamics in our subject Fluid Mechanics and Hydraulics. Okay. So first of all, in this module, what do you mean by the term called Fluid Kinematics and Fluid Dynamics? Okay. So what is Fluid Kinematics? We also studied in our introduction lecture. There are mainly three branches of fluid mechanics. First branch was fluid static. Till date we studied all the chapter where fluid was in steady condition, fluid was in rest condition. So that branch of fluid mechanics is called fluid static. Now second branch of fluid mechanics is fluid kinematics. Now in a fluid kinematics, the fluid is in motion. In a fluid static, fluid was in steady condition, but in fluid kinematics, fluid is in motion, but we are not considering the pressure forces for movement of the fluid. Remember that in a fluid kinematics, fluid is in motion without considering forces for that motion. Okay, and now third branch of fluid mechanics which is called fluid dynamics. Now in a fluid dynamics, remember that in a fluid dynamics, fluid is in motion, fluid is in moving condition, but here with consideration of pressure forces for that motion. Okay, remember that the difference between fluid kinematics and fluid dynamics, in both branches of fluid mechanics, the fluid is in motion. Okay, so fluid is in motion, but in fluid kinematics, the fluid, we are not considering the forces for that motion, and fluid dynamics, we are considering forces for that motion of the fluid. Clear the difference between fluid kinematics and fluid dynamics? Okay, so let's start our chapter. To understand the movement of any fluid, when fluid is in motion, to understanding movement of any fluid, you need to require basic knowledge of some lines, that lines of flow to describe the motion of the fluid. What are the lines? Yes, first that is a path line, second is your streamline. We will discuss all this line in detail in our further lecture. So first remember these names: path line, second is your streamline, third is your fourth is your strict line, and fifth is your potential line. You need to require to understand all these lines in detail for motion of the fluid. So let's start with our first line, which is called path line. Now the path traced by single fluid particle, mark my words, that a path, any path traced by single fluid particle which is in the motion over a long period of time, that is called path line. Movement of any single particle over a long period which is in motion, so that line, that path of that particle is called path line. As you can see in this diagram, that the line indicated with pink color, that is your path line. Any fluid particle moving on this line, moving that line is your path line. Okay, so the path line shows direction of velocity of the particle and it moves ahead. Path line indicates velocity of the particle. Clear? So first line was our path line. Now second is your streamline. What do you mean by the term streamline? So a streamline is an imaginary line. Remember that streamline is an imaginary line which is drawn through a flowing fluid. Here fluid is flowing such that tangent at each point. Here you are drawing tangent of line. So tangent at each point on the line indicates the direction of the velocity of the fluid particle at that point. So simply, if you are taking any line, okay, selecting any point and you are drawing tangent of that point, so that tangent indicates velocity of that flow. Streamline is a imaginary line. So if here we are taking all three lines, now in these three lines, if you are drawing tangent, which is highlighted with your red color, that red lines, so this tangent, it indicates the velocity of flowing particle. Okay, so it shows the position of various fluid particles, and streamline cannot be intersect with each other, they are always parallel to each other. Remember that the streamline are never orthogonal to each other, they are always parallel to each other. This is also example for the streamline. As you can see a fish here, and here you are taking tangent of any line, that gives you velocity of this direction of the moving fish. Clear? So this was our second line, which was streamline. Now our third line is strict line, which is also called filament line. Now what do you mean by the strict line? So a real line showing a picture of position of all fluid particle in the flow which have passed from the given point. This is a line which indicate the position of all fluid particle which is passing from one particular line. So there are some examples. You can clearly identify in strict line. A smoke from the chimney is the example of a strict line. So as you can see that here there is a smoke coming out from the chimney. So this movement of this smoke particle is an example for the strict line. There is another example for the strict line, that the gases is example for the strict line. Okay, so we completed three lines: path line, streamline and strict line. Okay, you can clearly identify type of flow if you know the movement of all three lines. So now our next theory, which is type of fluid flow. Type of fluid flow. So basically, as you can see that there are mainly 6 types of fluid flow. Okay, so first type of fluid flow is steady and unsteady flow. First type of fluid flow is steady and unsteady flow. We will discuss all 6 types of flow in detail in this session. The second type of flow is uniform and non-uniform flow. The third type of flow is laminar and turbulent flow. Laminar and turbulent flow. Now our fourth flow is compressible and incompressible flow. Fifth type of flow is rotational and irrotational flow. And our last 6th type of flow is 1, 2 or 3-dimensional flow. Now we will discuss all 6 types of flow in detail. Okay, and again this theory is also an important theory as your exam point of view. This is a very important theory which is also asked in exam so many times. Okay, so let's start with our first type of flow, which is steady and unsteady flow. Now first type of flow is steady and unsteady flow. As the name indicates itself, steady. So the steady flow, that type of flow in which fluid characteristics like velocity, acceleration, pressure or density do not changes. Remember that do not change with respect to time at any point. So that flow is called steady flow. Fluid characteristics do not change. That type of flow is called steady flow. So you can write down that del V by del T, so change in velocity with respect to time, change in pressure with respect to time and change in density with respect to time equals to 0. So this kind of flow is called steady flow. Now second is your unsteady flow. So if fluid particles changes, if the fluid characteristics are changed with respect to time, so that flow is called unsteady flow. So you can also write down here del V by del T, del P by del T and del rho by del T not equals to 0 for unsteady flow. So second type of flow, which is uniform and non-uniform flow. Okay. First of all, uniform flow. So when the velocity of the flow does not change, velocity of the flow does not change along its direction of the flow at any point of given time, which is called uniform flow. Here velocity with respect to distance does not change at any point. That flow is called uniform flow. So you can write down that del V by del S, velocity with respect to distance, equals to 0. Change of velocity with respect to distance equals to 0 for uniform flow. As you can see in this diagram, we are considering a circular pipe here. When a fluid element enters, then velocity in element of fluid throughout the pipe is constant, which is V. So there is no change in velocity at any length of the pipe. So flow in this pipe is called uniform flow. Okay. Now second is your non-uniform flow. So when as you can clearly identify the difference between uniform and non-uniform flow, if velocity changes over a length, over a direction of the flow at any point, then that type of flow is called non-uniform flow. There is a change of velocity, so you can say that del V by del S not equals to 0. Then that type of flow is called non-uniform flow. For that, you can consider this diagram. There is change in velocity over a length of the pipe. As you can see that when fluid enters, the velocity of fluid was V1, and in this second pipe the velocity of fluid is V2. So there is a change of velocity in some length of the pipe at different points. So this type of flow is called non-uniform flow. Now our third type of flow, which is laminar and turbulent flow. Okay. So in a laminar flow, fluid particles are moved in layers. Remember that fluid particles are moved in layer with each other or sliding over each other. So that type of flow is called laminar flow. In this diagram, as you can see that diameter of pipe is D. All the fluid layers are parallel to each other. So this type of flow is called laminar flow. For the laminar flow, Reynolds number must be less than 2000, or you can say that if Reynolds number, which is rho Vd upon mu, if Reynolds number is less than 2000, then your type of flow is laminar flow. Now next type of flow, which is turbulent flow. Now in a turbulent flow, in this diagram, what you can see? All the particles are moving parallel or not? No. All the particles are moving in a very zigzag way, in a very random way. So flow in which the adjacent layer cross each other and layers do not move on well-defined path. Here particles are not moving on particular defined path. They are on zigzag way, random way. So this type of flow is called turbulent flow. This type of flow is called turbulent flow. As we know that Reynolds number is less than 2000 for laminar flow. So for the turbulent flow, Reynolds number must be greater than 4000, or you can say the flow is turbulent if Reynolds number is greater than 4000. Now our next type of flow is compressible flow and incompressible flow. Okay, first of all, what do you mean by this term called compressible and incompressible? Is liquid is compressible or is liquid is incompressible? Okay, so the volume and density of the fluid do not remain constant. Density do not remain constant during the flow passing. That flow is called compressible flow. So you can say that gases are always considered as a compressible fluid, because here density in the gases is not remain constant. So gases are always considered as a compressible fluid, and on the other hand, in an incompressible fluid, the flow where density changes, so that fluid is called incompressible fluid, and normally the liquid are considered as a incompressible fluid. Remember the difference for compressible and incompressible. In a compressible fluid, density do not remain constant. Here density remain constant. So volume, here volume changes, here volume do not changes. So gases are considered as a compressible fluid and liquid are considered as a incompressible fluid. Okay. Our next type of fluid is rotational and irrotational flow. Okay, rotational and irrotational, as its name indicates, rotational and irrotational. So in a rotational flow, the fluid particles rotate about their own axis. Remember that fluid particles rotate about their own axis while flowing along the streamline. This is called rotational flow. As you can see in this diagram, in the first diagram, the particles are moving about their own axis. So that flow is called rotational flow. Now motion of the liquid in a rotating cylinder is a rotational flow. Okay. Now we will see irrotational flow. So as per diagram number 2, as in second figure, the fluid is locked by that both sides. The fluid is locked. So fluid particles do not rotate about their own axis. They can move. Fluid particles can move, but they can't rotate about their own axis. Then that type of flow is called irrotational flow. So the fluid particles do not rotate about their own axis while flowing on a streamlines, which is called irrotational flow. You can clearly identify that flow, rotational and irrotational. In a rotational flow, the movement of fluid particles like this. Fluid particles are moving and rotating about their own axis. But in an irrotational flow, the particles are moving like this. They can't rotate about their own axis. Okay. And so flow of water in an emptying wash basin is a example of irrotational flow. Now our last type of flow, which is 1, 2 and 3 dimensional flow. First of all, for that you need to understand this diagram first. Okay, there is a cube which is placed in all three directions, x, y and z. This is your direction x, this y, and that direction is your z direction. Okay, now velocity of fluid. Remember that velocity component of the fluid in x direction is always indicated as u, small u. Velocity component in y direction is indicated as small v, and velocity component in z direction is always indicated as small w. You have to remember all these terms u, v and w for direction x, y and z. Clear? Now first we are considering our first, which is one dimensional flow. So the flow parameters such as velocity is a function of time and one space coordinate. Function of time and only one space coordinate, say x. So which is called one dimensional flow. So you can write down that u, that is velocity in x direction. So u equals to f of x Here v, that is velocity in y direction, and w, that is velocity in z direction, equals to 0. So for the one dimensional flow, you can write down u equals to a function of x, v and w equals to 0. Now for the two-dimensional flow, the flow parameters such as velocity is a function of time and two space coordinates. Here in a two-dimensional flow, it is velocity is function of time and two space coordinates such as x and y. X and y, that is called two-dimensional flow. So you can write down u, v and w. So u is a function of x and y. So u equals to f1 of xy, v equals to f2 function of x and y, and there is two-dimensional flow only, so w equals to 0. Okay. Now same for three-dimensional flow, the velocity is a function of time and three space coordinates. Time and three space coordinates, say x, y and z. So it is called three-dimensional flow. So what you can write down here? Okay, yes, u equals to f of 1, x, y and z. Here we are considering three-dimensional flow. So there are all three direction involved here. So u equals to function of x, y and z, v equals to function of x, y and z, and w is also a function of x, y and z. Clear? Okay. Remember that velocity component in x direction is u, velocity component in y direction is v, and velocity component in z direction is w. Small u, small v and small w are the components of velocity in x, y and z direction. We will use this velocity components or this indication in our whole chapter. Okay, so remember this. So, okay students, now in today's lecture, we completed our theory which is called types of fluid flow, and we also learned some lines which are important for basic movement of the fluid. Now in our next lecture, we will go through the continuity equation. So, done for the today. Goodbye. Thank you.